Welcome back. Last time what we looked at is we looked at the demand picture for our global food picture. Now what we're going to do is we're going to take a look at the supply side. And so we more or less indicated that the need for cereals was going to increase from 2.1 to 3 billion tons by 2050, according to a FAO study done about 10 years ago. And also meat was going to, the demand for meat, or the need for meat, was going to more than double, moving from 200 million tons to 470 million tons. In terms of looking at this, the FAO, that same study, estimated that 90% of that is going to need to come from crop production through higher yields and increasing cropping intensity. And so in some respects, this is going to be the whole issue of productivity. The fact that 90% of that food demand is going to have to come from increased productivity. In terms of, if we look at this with regards to the other aspect, is arable land. And essentially what this indicates is, the study indicates 120 million hectares. Again, for those of you that are in acres, a quick conversion is multiply that by 2.5. So if you take 120, multiply that by 2.5, that ends up being 300 million acres. And so the aspect is that over the next 30 years, we're going to have to find 300 million acres of land, or 120 million hectares. Certainly that sounds like a big number. One of the things to think about is just, where is our arable land now? What is that number for arable land? It does have to increase by 120 million hectares. What percentage is that? And we'll come back to that, but it's something to ponder as we look at this big number of 300 million acres, or 120 million hectares. To give an indication, essentially the number in Kansas is 40 million acres, and so it's adding about 7.5 Kansases in order to get that 300 million acres. And so is there that possibility? One of the things I think that's very important is really to look at precipitation, in terms of it's difficult to grow crops without precipitation. And so if we look at that, certainly we can see where we are in North America. Obviously, as it gets darker blue, basically that is more annual precipitation. And then if we look through kind of near the equator, one of the things you end up seeing is that basically there's just a lot of dark blue there. And so there is the possibility with regards to rainfall. You may end up saying, in terms of, okay, well, with all the rainfall there, with all the rainfall there, with all the rainfall there, just why did production develop more in North America than maybe it did in other regions? Well, in addition to rainfall, the other thing that really matters is soil quality. And so again, this is a map of soil quality, and red basically means there's low penetration, and so the soil water holding capacity in red regions is very low. In yellow regions it's moderate, and in green regions it's very high. In terms of, to give an indication, if we look at the big major production area in the US, a lot of yellow. If we look at it kind of in that region of Brazil, in some respects it's red, and so they have low water holding capacity. In some respects, that explains why sometimes in the growing season in Brazil, they don't have rain for a week, and all of a sudden the crops are in very precarious situations. In the northern hemisphere, for example, North America, you don't get rain for a week. It's not good, but usually crops can sustain themselves through that. Part of that, again, is just the water holding capacity. It's just so much better. In Brazil, there's a lot of soils where it's about 5%. In the U.S., in the yellow, a lot of cases it's about 20%. And so it can hold 3 to 4 times as much water as you get in certain regions. We look at Africa, certainly there's a region there with pretty good soils. And then if we look at Southern Asia, in some respects, India has some of the best soils in the world. Certainly Argentina, Uruguay have pretty fantastic soils. In terms of can water holding capacity change? In some respects, again, from my soil analysis, one of the things you want to do to soils is add organic matter. And by adding organic matter, basically that can improve the soil water holding capacity. Is that a quick process or is it a slow process? It usually tends to be a fairly slow process, but again, this is where you do have some of the tillage, reduced tillage, no tillage being adopted around the world. A lot of it is just for that ability to increase the soil water and holding capacity. And so in terms of looking at future production areas, certainly we've seen a big increase, and we'll show you some numbers on that with regards to the Brazil region. And in some respects, the big question is, can we end up seeing that in Africa? There are parts in Africa there where the soils and the rainfall do add up pretty well, such that perhaps that would be a possibility. And then the other region up here is certainly in the Ukraine region. Europe has pretty good soils with that perspective. One of the questions I asked previously is just where are we from a global arable land perspective? We need to add 120 million hectares. Basically, this kind of gives us where we are over time. One of the things to look at is right now we're pretty close to 1.4 billion or 1,400 million hectares. And so if we add 120 divided by 1,400, it ends up being 7 to 8%. If you look at where we were in 1960, essentially we're about 1.25, someplace in there. Essentially we increase rather steadily up until kind of the 1980s. You can see generally a decreasing trend to about 2007, and then after 2007 we generally had an increasing trend. And so again, if you look at that, people always say the old adage, they're not making any more land. Well, in some respects we are making more land in terms of we actually are farming or have more arable land now than we did in 1961. And in some respects, the issue is whether or not we can grow that up until kind of in this 1.5 billion hectares of arable land. That's kind of what's needed in order to essentially meet at least what FAO requirements are. And we'll kind of take a look at this. This next graph basically, and I'm using this information from FAO Stat. Basically, these are the top 10 countries for arable land, and the most recent data is 2017. The U.S. has passed India in terms of, for a while the U.S. was behind India, but now it's recaptured. And so the U.S. has the most arable land, followed by India, followed by Russia, then China, then Brazil, Argentina, Canada, Nigeria, Ukraine, and Pakistan. And so essentially over, if you look at these top 10 countries, it turns out that they end up making up roughly 58% of the arable land. And so roughly 3 out of 5 acres or hectares in the U.S. of farming ground is in one of these 10 countries. And then the other roughly 100 and some countries around the world end up consisting of 2/5 of the arable land. If we look at what's happened over or since 1960, one of the things you'll see is that the U.S. here has actually decreased in terms of certainly with some of the urbanization and conversion of farmland to residential housing around the major cities. Also the CRP is in there. In some respects we've went from about 190, not quite 190, down to 160, and so essentially we've essentially lost about 30 million hectares, although you can see that there seems to be a slight uptick since about 2012 in the arable land. You can see in some respects that India has remained about that 160 million hectares over the whole time, and so there just hasn't been much movement. And part of it is if you ever have the opportunity to travel to India, one of the things you'll notice is that they use every inch of arable land that there is there, and so in some respects it does make it difficult. In terms of third place, you have Russia. Essentially, they've started in 1992. Essentially, they're down about 10 million hectares since the Soviet times. In some respects, really, since about 2004, 2005, it's been pretty level. Next, you have China. In some respects, there was a decline, and then all of a sudden, from 2014 to 2015, it increased. Again, these are FAO numbers. Sometimes it's difficult to explain in terms of what this rapid increase was, whether or not it was just an adjustment in the way they measure data or not. It's certainly unclear, but certainly you can see that China is pretty close to 120 million hectares. And so, again, if you look at the FAO study, we're essentially bringing on another China. The line in blue there, and in some respects probably most impressive in terms of if you look at that, it was in the low 20s in 1961, and in some respects now Brazil is beginning to approach 60 million hectares, and so roughly over this time they've had a 200% increase in arable land, and we'll discuss that a little bit more over time. And then you can kind of look at some of the other countries: Nigeria, Pakistan, Ukraine, Canada, Argentina. Certainly they're all in there. There has been, in some respects, some increase in Argentina from about 2003 to 2011. But again, a lot of stability over time with regards to the arable land. And so maybe to summarize this amount, the top 10 countries do make up 58% of that arable land. Global arable land generally increased from 1961 to 1991. It fell slightly to 2007. And then after 2007, it has increased steadily since then. Again, not a big growth, but certainly slightly. To give you an indication, in 2017, we actually had 9.2% more land than 1961. And so roughly over this 55 year period, essentially we've increased the global arable land by almost 9.5%. In terms of, you can see from 1961 to 1991 how essentially it slipped. Essentially, we're only 1.3 more in 2017 than we were in 1991. And then essentially you look at where we are in 2007, we're about 3.2% more. And so essentially we have seen a general increase in that arable land since 2007 forward, and so essentially it kind of matches the trend there. And so what about 120 million acres, and again, or hectares? And again, taking a look at this, there are some estimates there that I think are important. The most recent estimates that I've seen, and there's also some studies from Brazil that kind of indicate that, is that there's about 145 to 170 million hectares of land that could be brought into crop production in Brazil. In terms of, you look at that compared to the 120 million hectares needed, and you can all beginning to see, well, maybe I don't need to be so Malthusian in my thought process, simply because perhaps Brazil could end up doing it alone. One of the things, though, people always get concerned about is what is that going to do on the environment. The estimates is that there's 10 million hectares in the Amazon region that may come in through deforestation. 65 million hectares in the Cerrados region. The Cerrados region is kind of that western part of Brazil that we've seen a lot of increase in the production. Roughly, there's about 65 million more hectares. And again, the general picture of that is kind of a scrub land where you have kind of a lot of bushes and woody type things. And so you got to be careful there saying whether or not it's scenic or not, but certainly in my opinion it's not a very scenic landscape to look at. And then the other thing that I think is very important is there's roughly 70 to 90 million hectares from pasture that can be converted. And if you go back in the U.S. into the 1950s, 1960s, there was a lot of pasture in Illinois, in Iowa. However, since then, basically, we don't have much pasture in Iowa, Indiana, Illinois. What happened? Essentially, basically, that pasture was converted to cropland. What drove that? Basically, it was the economics in terms of corn and soybean production became more profitable than pasture. And so essentially, that land was converted from pasture into crop production. In terms of looking at that, did it have a big environmental impact? Some would argue it did, some would argue that it didn't. But in some respects, the land that was converted probably didn't look a lot different than what was being grown in crops at that point in time. In some respects, it's the same with regards to Brazil. In terms of if you look at what's pasture versus land that's cropped, essentially there isn't a whole lot of difference with regards to that. And so certainly in some respects, I think that conversion to pasture into cropland could be a huge issue. Currently, that's growing cattle, and so where will those cattle go? Will that essentially reduce the cattle herd, or perhaps might another system be developed? And I think that's one of the things to watch at if we do see increasing crop profitability in the future, whether or not that will cause conversion from pasture into cropland, and whether or not that will move cattle. Probably they won't be raised in Brazil simply because of the temperature, but in some respects the issue is would they move south into perhaps Uruguay, into southern Paraguay, into Argentina, where the climates would support more of the English breed as opposed to more of the African breed and Nelore cattle that are typically raised in Brazil. But certainly that's going to be an issue to think about into the future. In terms of one of the things to look at, there is a 1 to 5 ratio. And so essentially for every acre converted in the Amazon region, you have to have 5. And so you farm 1, you leave 4 there. Essentially, it's kind of a 1 to 2 ratio in the Cerrados region, where for every acre you convert of the Cerrados, you have to have 2 acres. And so 1 has to lay idle. And so certainly there is that aspect. Another place we could get 20 million hectares is essentially Russia. Under the Soviet times, basically, we're producing more, and so the estimate is that you could get about 20 million hectares of land that went out of production in Russia. The U.S. has 12.5 million hectares roughly in the Conservation Reserve Program. Again, that could be a policy decision in terms of whether or not that's there. In terms of looking at this, you can easily see where 120 million hectares could be possible. And we haven't even talked about other regions in terms of, we haven't talked about Africa and some of those other regions around the world. And so from that perspective, I think the 120 million hectares is a possibility. I don't think it's out of the question when you begin to do an accounting of what is the possibilities out there. The other thing, and what we're going to finish up now, is the whole aspect of productivity. If we look at productivity, here I have the global wheat yield from 1961 to 2018. And in some respects, it's in hectograms per hectare. And again, you can do the calculation into bushels per acre if you want. The big thing is just looking at the trends. One of the things you'll see is that in 1961 was kind of in that basically 7,000 to 15,000 hectograms per hectare. You'll see a steady increase, and essentially now we see a wider spread. In the Oceania region, we're down about 15,000 hectograms per hectare. In Europe, we're up about 40,000. And so in some respects, you've seen a generally trend. I'm going to use the same colors as we move forward on this graph, so the black is always the world. But basically, in some respects, kind of in the 1980s, since then, the European Union, or the European countries really had a substantial increase in wheat yields, and all the rest have kind of trended around the world numbers. Probably where we've not seen much improvement is kind of in the Oceania region. The next graph is basically at soybean yields. One of the things to look at is that certainly there's a wide spread from about 17,000 hectograms per hectare down to about 4,000 in 1961. One of the things you'll see is that certainly North America has created some dominance, but in some respects we've seen some increasing, a quicker increase in South American yields over this maybe last 30-year period, where essentially there's some catching up, and there have been years where the U.S. production wasn't so good. Brazilian production, South American production was good, and so there actually has been some catch up there, and years where actually that was ahead. Again, you can see that Africa's lagging behind, Asia's lagging behind with regards to the productivity there, Oceania in Europe. And so if you really look at it, the big regions there are going to be North America and in South America. If we look at maize yield, one of the things you'll see is, again, just the dominance of the U.S. from about 40,000 to nearing about 120,000. And so over this 57-year period, essentially we've almost tripled the amount of production on a per acre per hectare basis. You see that Oceania has pretty good yields. Europe has some pretty good yields. In some respects, you see quite a bit of lagging with regards to South America in Asia with regards to the yield. Although if you look at kind of where South America was in 1991 to where they are there, essentially they've tripled their yields over the last essentially 25, 26 years. And again, this is data through 2018. So to maybe summarize the annual yield growth from 1961 to 2018, I've kind of looked at it for each of the crops. I added rice in here, but from a world perspective, basically it's been 2% per year on maize, 1.65% on soybeans, wheat 2%, rice 1.6%. And so in some respects, you see wheat and maize kind of leading, and in some respects, soybeans and rice lagging. You can see where North America was in terms of certainly from a maize perspective, pretty close to the world average. Soybean perspective, not so good. Wheat perspective, not so good. Rice perspective, not so good. And some of that is that when you're moving the frontier where the U.S. is, it's harder to move the frontier where certain countries, especially South America, has probably enjoyed some catching up. And so they've seen an increasing move of the frontier, but they've always also caught up from a technology perspective. And so looking at that, that gives a little bit of an indication of where we are. You might argue, well, that's not fair, especially as we look ahead, because some of the easy technology gains were already occurred. And if you want to argue that, I'm not going to argue with you. What I've done here is basically I've looked at essentially the last 20 years data from 1998 to 2018, and essentially I've compared that from the overall average. The numbers in red basically indicate that we're not doing as well over the last 20 years than we had the entire period. And the purple numbers are places where we're doing better. One of the things to realize is that South America, in some respects, because of that catching up, have done extremely well. They're actually doing a little bit better than they had previously. In North America, we're actually seeing a little bit of improvement over the longer-term average. It's pretty slight in terms of you're looking at 1.35 to 1.31. And in Europe, in some respects, they're doing a little bit better from the rice perspective. But again, it kind of looks at these. And so in some respects, that goes back to the question in terms of, from a productivity perspective, are we going to meet the world's demand? And so yield growth has generally been less in the 1998 to 2018 period than previously. And so what I did is I just said, okay, let's say I take the last 20 years and project them out for the roughly next 30-year period, using kind of the growth rates from the world over that 1998 to 2018 period. Looking at that, wheat yields would increase by 50%. And so, for example, if you're looking at planting a 40 bushel wheat crop in 2020, you'd be looking at producing a 60 bushel wheat crop in 2050. Corn increases by 63%, soybeans by 47%, rice by 36%. In terms of, if you look at the FAO study, essentially cereals needed to increase over that period by 0.9% per year, or a total of 31.8%. And so looking at these, if we can replicate the technology gains over the last 20 years, and again, that's a big if, but if we can we produce those yields? And so looking at that, certainly it does appear that all of those are greater than the 32% that is needed, and so it seems like productivity can be there. Certainly there's contests and places where corn yields have been above 500 bushel per acre. Soybeans have been above that, and the seed technologies is there in terms of, is there the possibility of better delivering water, better delivering fertility in order to meet that. But in some respects, I'm not Malthusian in terms of the fact that technology, if we can replicate the last 20 years into the future, we should be fine. And certainly there's some pretty exciting technology coming on board. The other thing that I want to visit with a little bit about is the whole efficiency gain in post-harvest loss. And again, in India, you'll see all kinds of numbers. I saw some recently where 3/5 of the crop was lost. And so essentially of the fruits and vegetables that they raise, roughly 35 to 40% spoil and never see the market. In Africa, in 2008, maize, sorghum, and rice had losses of 22.4, 12.5, 12.5. And so essentially that crop was produced, it was harvested, and then it was lost and never made it to the consumer. In terms of Southeast Asia, in terms of rice, losses are estimated between 10 and 37%. And so if you look at that, basically this post-harvest loss represents a big economic opportunity. If we can better figure out how to preserve and store commodities that are already produced, we're already spending the water, we're already spending the fertilizer, we're already spending the currency in order to produce it, but then we don't get the economic benefit from that because of the losses that occur post-harvest. And so a big issue that in some respects needs attention as we move forward. And so if we look at the opportunities and challenges, certainly the whole risk aspect is going to be important in terms of there are years where crop production is good, there's years where it's not so good. The whole issue with regards to managing fuel production, the whole ethanol industry in some respects is a big concern in various parts of the world. In some respects, I've kind of used the analogy that when we started processing soybeans and crushing those, the main thing we were looking at, I believe, was oil. And meal was more of a byproduct, and people kind of argued what they're going to do with that. However, now if you look at it, essentially the value of the meal, the value of oil are both extremely valuable. As we continue in ethanol production, will we end up finding a better way to value the DDGs? And so when ethanol first was produced, the idea was to burn that. Then it was to put it in cattle feed. I think the next issue is whether or not perhaps it would even go into human consumption. Managing trade is a big issue in terms of looking at that. Certainly one of the things you'll see and have seen is that a lot of the production is going to occur in the Western Hemisphere. A lot of the people are going to be in Africa and in Asia. The issue is there going to be people moving to the food, or will we move food to the people? And currently, given the political climate, it seems like there's more interest in moving food to the people than having mass immigration around the world. That certainly could change, but with that, trade, I think, is going to be pretty important. Natural resources, again, the whole issue of managing natural resources is going to continue to be a huge challenge. And then the whole issue of dietary changes in health is going to be important. So as we summarize, certainly the food and agricultural sector must step up to meet the challenges of an increasing and changing population. It certainly is going to be difficult in some regions of the world to produce the amount of food demanded by local population. Globally, I think we'll be able to meet the demand, but you're probably going to end up needing to have a better understanding of global supply and demand. I don't know that we can just continue to focus on what the U.S. demand and supply is. I think we're going to have to look much more from a global perspective. And I think we're going to continue to see an increased emphasis on trade. Again, just where we are from a world perspective and a political perspective, political economy perspective, essentially, it appears that while people don't like trade, in some respects, people don't like immigration, and currently it seems like there's probably less dislike of trade than there is of immigration, but certainly that's going to be a continuing issue that countries around the world are going to need to wrestle with. And so with that, hopefully these two lectures have kind of provided an indication of the long-term picture of where we are globally in terms of a demand and supply perspective. Certainly in terms of the food and agricultural sector, the long-term prospects are very positive. Sometimes it doesn't feel like that in terms of where we are now, kind of struggling with supply and demand and having supply outstrip demand, causing low prices, low incomes around the globe, certainly within the U.S. But globally, in terms of with the population, with the changing income, there are going to be opportunities in the future. And so thanks for your attention. And with that, this will complete the session.